Welcome to this session. This session we are going to give examples on how to do composition of functions. So, composition of functions. So, first problem, if f of x is given by x squared plus 2x minus 5, and g of x is given by x cubed, find A, f composed with g, b, g composed with f, c, f composed with g at 2, d, g composed with f at minus 4. So part C and part D cannot be found without having A and B. That you should be taking that one into consideration. You can't get C and D if you don't know A and B. So let's evaluate this. Solution. F composed with G, so these are functions of X, means F of G of X, which means F and then G of X is given by X power 3. And how does F function operate? You give it an X, it will square it, add twice the same X, and then subtract 5. So when you give it X power 3, it will square it, and then sum to twice the same input, and then subtract 5. So that x cubed squared is x power 6 plus 2x power 3 minus 5. Remember, loss of indices, a power m raised power n is a raised power m times n. So 3 times 2 is 6, not 5. So next one, so this is A, B, G composed with f of x means G, and then f of x becomes your input. So it'll be G, f of x is x squared plus 2x minus 5. And how does G operate when it's given any input? It simply raises to power 3. So we'll have x squared plus 2x minus 5 raised power 3. So we need not to open. But these are simple expression you can always open, but this is still fine. Now, so then we can now comfortably answer part C and D. So part C says f composed with G at 2. This means the function you have gotten as f composed with G, this one here, we replace where there's x by 2. So it'll be 2 raised power 6 plus 2 into 2 raised power 3 minus 5. So this one we have 2 raised power 6 plus 2 into 2 raised power 3 and then minus 5 will be 75. And then G composed with f at -4 G composed with F at -4 means this answer we have gotten here will replace where there's X by -4. So it will be -4 squared plus 2 minus 4 minus 5 raised to power 3. So this would be, so we have answer squared plus twice answer minus 5 raised to power 3. That will give us 27. And then question 2. Number 2, if f of x is given by 2 over x plus 1 and g of x is given by dx, find A, f composed with g, B, g composed with f, C, f composed with g at 1, and D, g composed with f at 2. So here, solution A, so f composed with g will be f, then g becomes the input. So the g function is 3x. And when you give f any input, it takes twice over the input plus 1. So we'll have 2. Input is 3x, then plus 1. And then part B, g composed with f of x is g of f of x, which is g, f of x is twice 2 over x plus 1. And when you give a function called g any input, it multiplies by 3. So it does the same thing. Multiplying this one by 3, we get 6 over x plus 1. So C, when they tell us to find f composed with g at 1, simply means where there's x in this function, A, we replace by 1. So we'll have 1 over 3 times 1 plus 1, which is 1 over 3 plus 1, which is 1 over 4. And lastly, g composed with f at, that's 2, at 2, means we replace here where there's x by 2, so we'll have 6 over 2 plus 1 is 6 over 3, and the answer is 2. And then number 3, if f of x is given by 2x cubed minus x squared plus 4, and g of x is given by 3, find A, f composed with g, B, g composed with f, C, f composed with g at 3, and D, g composed with f at 4. So to solve this, A, f composed with g is the same as f of g of x. which is f g of x is 3. When you give f any input, it takes that input, raises to power 3 multiplied by 2, subtract the same input squared plus 4. So we'll have twice the input raised to power 3 minus the input power 2, and then plus 4. So we'll have twice answer power 3 minus answer squared plus 4. That gives us 49. And then B, G composed with F means G becomes the function, F becomes the input. It will be G of f of x is 2x cubed minus x squared plus 4. Now, how does function G operate? You give it any input, x, it will always give you a constant 3. So regardless of the input we are giving G, it will always give us a constant 3. So this remains to be 3. And then C, F composed with G at 3. So remember, F composed with G of f of x is 49. So if f composed with G of x is 49, then it means that whenever you give this composite function and any input x, it will always give you a constant 49. So therefore, this doesn't change. It remains to be 49. And then G composed with F at 4. G composed with F at 4. Now remember the definition of G composed with F of x from B, we have gotten the answer to be 3. So whenever you give this composite function any input x, it will always give you a constant 3. So therefore, the value of this one also remains to be 3. That's how we solve those problems.